An unusual calculus problem made by ways to solve. To solve this problem you are required to have an IQ of 150 and have taken Calculus 1, 2 and 3. Just kidding. In all seriousness, you should know Calculus 1 to solve this problem. It might look terrifying, but it isn't. It's only tedious. Can you solve it? Pause the video and try this on your own. Some of the things we notice is in the numerator, there's a square root. Another thing that we notice is that the whole problem is being raised to the 10th power. For the numerator, we can write it as 10x to the 10th power plus 10e to the x all over x 10e to the x raised to the 1 over 10 power. According to the chain rule, whatever exponent anything is raised to, bring that exponent down, multiply it with the original function which will later be raised to the original power minus 1, and multiply it with the actual derivative. Now comes the tedious part where we have to take the derivative of the whole thing. So, that would turn out to be 10 times 10x to the 10th power plus 10e to the x over x 10 to the x power raised to the 1 over 10th power. All over 10 minus 10x over 10 raised to the 10x plus 10 minus 10 raised to the 9th power. Just to leave some space we're going to be leaving the rest of the equation alone, and just focusing on finding out f prime, and later we'll attach it to the rest of the equation. Since we're working with a fraction we have to use the quotient rule, which is g times f times g prime per gram squared. What we're going to do here is let f equal to the numerator and g equal to the denominator. What we can do is now use the chain rule to solve out for f prime and g prime, but to find out the inner derivative we have to use the quotient rule. Now if we put it all together this will be our answer. 10 times the actual function raised to the 9th power multiplied by g times f prime minus f times g prime all over g squared.